So this is the video of the Inspired document for midpoint, slope, and distance. It's the review Inspired document that I have mentioned in your summer assignment handout. This accompanies the midpoint slope distance gift as a PDF. If you printed out that PDF, that's great. You don't have to. You could write everything down on separate notebook paper or graph paper. You will have to graph a few problems, so graph paper is preferred. If not, if you're doing this on notebook paper, anytime you go to draw a coordinate plane, please draw it very neatly with a ruler and indicating the units of how you're numbering. Make sure that they're evenly spaced. So again, use a ruler for that. So you can follow along here. You will not need your calculator. This video will just show the Inspired document that you would have seen had I transferred this to your calculator. So we're looking at this to understand all of these formulas here graphically and then algebraically. So some of this is just going to be a repeat, taking you through, again, what this video will be over. Again, you do not have to write on the gift if you did not print it out. All right, so we're going to start first with midpoint of a segment. Please make sure you write this definition down. Right here, that's in the middle. A midpoint of a segment is the point on the segment that separates the segment into two equal parts. It has to be right in the middle. So here's just a nice visual for this. Notice that point M is a midpoint of segment AB. Point N is the midpoint of segment CD. The coordinates for point M are 5, 4. The coordinates of point N are 14, 3. Kind of looking at the endpoints there for A and B, kind of look at the X values and then look at the X value of the midpoint, then go to the Y values for points A and B, and then look at the Y value of point M. Likewise for line segment CD and the midpoint N, and see if you can remember the process to calculate the midpoint. Again, this is just a definition repeated. You already wrote it down once. So again, just going back over it, a midpoint of a segment is the point on the segment that separates a segment into two equal parts. Now on the next page, I'm going to do this though, but just to show you how the points can move. So again, I have 2 points here on segment AB. I have 4, 11 for point A, 14, 3 for point B. Notice the midpoint, the ordered pair there is 9, 7. Again, think about the relationship between the X values of all 3 of these points and then the Y values. I'm going to go ahead and move point A right about there, so I get another nice ordered pair. And again, see if the relationship you were thinking of holds true when I have point A moved to a different location. So instead of using actual ordered pairs, we're going to just create generic ordered pairs and just have an X sub 1, X or Y sub 1, and then an X sub 2, Y sub 2. Written out as such. And then see if you could write out the formula using these X's and Y values here to calculate for point M. All right, so under the definition, and please make sure no matter what section of the summer assignment you're working on, please make sure you label it very neatly. We want to be able to keep track of all of the pieces of this summer assignment. I will be checking once we return to school. So go ahead and write the midpoint formula on page 1 of the gift or right underneath the definition on your notebook paper. But this is it. So in order to find the X value of a midpoint, we simply take the average of the 2 X values for the endpoints, and then the same for the Y's because it has to be right in the middle. Go ahead, pause the video, do problem set 1 on the gift, resume playing the video, and I will show you the answers immediately. So pause this, go ahead and work on this, and then continue playing. Okay, so again, only look at this part if you're ready to view the answers, keeping in mind it's to your benefit to know how to do these problems, not just copy down the answers. We need to know how to do these types of problems like second nature when we're working on other problems throughout this course. So again, it's to your benefit to really know how to do these. But let's go ahead and check out the answers to problem set 1. All right, for part 2, we're going to be looking at how to generate the formula for slope of a line, a variety of ways to refer to the slope of a line. All right, so a couple ways to refer to the slope. It is going to be a number. More often than not, it's a fraction because we could turn any whole number or integer into a fraction as well. And it indicates to us how slanted a line is. Does it have a positive slope, a negative slope? So we're going to review the 4 types of slope as well. All right, so all lines that, as we look from left to right, move uphill or increase will have a positive slope. Just the opposite, all lines that slope downhill from left to right have a negative slope. Any horizontal line, it has a run but no rise, so we say the slope is 0. All horizontal lines have a slope of 0. And vertical lines, I always like to use the word undefined. It has a rise but no run. So a lot of times you might see no slope, but I don't want you to get that confused with the slope of 0. I like to say the slope is undefined because technically we would have any kind of number over 0, which is undefined. Go ahead and pause the video now, and on the gift, do problem set 2. Then you can resume playing to see the answers. Check your answers there. Again, only proceed if you have completed problem set 2. Here are the answers. All right, so again, reviewing, that slope is going to be a number if we're asking what is the exact type of slope, not if it's just positive or negative, 0 or undefined. So algebraically, how we're actually finding the slope here, we will look at these graphically too, but recall that slope is a fraction that indicates rise over run. The rise comes from the change in y's over the change in x's is how we calculate the run. So we use this Greek letter delta, looks like a little triangle. It's delta y, which means the change in y's, over delta x, which is the change in x's. And this allows us to come up with a formula to show how we're subtracting the y values for delta y and we're subtracting the x values for delta x. So it's the rise over run, change in y's over change in x's. Keeping in mind we use a lowercase m to indicate slope. So to find the slope of a line graphically, first decide if the slope is positive, negative, 0, or undefined. We create a right triangle, then we find the distance or the length of the vertical leg. That's going to be delta y. The length of the horizontal leg is delta x. We make the appropriate fraction, bringing the appropriate sign back into play. So within this document or the gift that you're going to be working on, so if I ask you to show anything graphically, you're just going to plot the points on the graph, create your right triangle, show that delta y is equal to whatever value, delta x as well. So you're going to see this on the next page here. All right. We want to decide if the slope is positive, negative, 0, or undefined. Notice that the line is going downhill from left to right, so this will have a slope that is negative. If I just indicated 2 points on this line and then I would create a right triangle from this, notice the vertical leg here, I'm going to write that delta y equals and then I'll count for the rise, and then along the bottom I'll have delta x equals and I'll count that for the run. So this is what I'd like to see. This is how you're going to tell me or show me your work for this part. So on the gift that I'm giving you, this is what I'm going to want to see. The 2 points here, and then the horizontal and vertical lines, as well as delta y equals and delta x equals. So this is how you're going to show your work graphically. So here the slope is going to be 6 over 11, but it's negative because the line is slanted downhill from left to right. Go ahead and pause the video, work on problem set 3 on the gift. Okay, notice it does say for these 4 problems to simplify all fractions. If you were doing this on your own paper, that means you just want to find 2 nice points, kind of recreate the coordinate planes, draw the line and find 2 nice points, create your right triangle, and show that way. I'm just going to show the answers here. But what I'd like to see on your paper is what delta y is equal to, delta x is equal to, and then indicate what the slope is. All right, so here we're now using the slope formula, so we don't always have to try to graph our line or regraph it if you're looking at a picture. To indicate delta y, we simply did a y2 minus y1, delta x is x2 minus x1. And all that really means is whatever y value we start with, for the rise, we want to start with the same x value, or the x value from the same ordered pair. So technically this could say y1 minus y2 over x1 minus x2, but we typically see it this way. All right, so here's an example of just two ordered pairs without having to graph. So we have x1 is -3, y1 is 2, x2 is -1, and y2 is -6. So using the formula very carefully with our negatives, y2 minus y1 becomes -6 minus 2, x2 minus x1 is -1 minus a -3, and then we just simplify numerator and denominator. Getting a -8 over 2, always put fractions in lowest terms here, so we get a -4. To confirm this graphically, you see we have the 2 points plotted, a line segment drawn within them, the horizontal and vertical legs here. Notice at the bottom here, it showed up right down here, but delta x is 2, delta y is 8. We know we have a negative slope here because our line is downhill from left to right. Go ahead and pause the video, do problem set 4 on the gift. Only proceed now if you wish to see the answers. Again, these are just the fractions for the slope here. To verify graphically, you want to plot the 2 points that are given, make your right triangle indicate what delta y and delta x are. Go ahead now and do problem set 5 on the gift. Only proceed now if you wish to see the answers. Again, here all you had to do was use the slope formula. Now for number 2, the slope is undefined. If you notice here, both x values are the same. Whenever that happens, you know your points are going to line up vertically, and any vertical line is going to have no slope or a slope that's undefined. If you actually calculated the values here, you would have 0 in our denominator, and we can't divide by 0, so that's another way to arrive at the undefined answer for the slope. Just the opposite here for number 3, our y values are the same in the ordered pair. Anytime that happens, we're going to have 2 points that line up horizontally, draw a horizontal line there, and we have a slope of 0. Or in this case, our rise, our numerator was 0, and 0 divided by anything is still 0. Okay, last we're going to look at the distance formula. Again, it comes from the Pythagorean theorem, but we're first going to look at how we can show this graphically. So go ahead and make a coordinate plane, plot these 2 points, then make a right triangle. We want to find the lengths of the legs, and then, like I said, we're going to use the Pythagorean theorem. So pause the video now to regraph or create a new coordinate plane and plot these points. Okay, go ahead and make a right triangle. And just as we did before, we want to find the length of the horizontal and vertical leg. You don't necessarily have to call them delta x or delta y. It's not wrong if you still do, but we're just looking at the legs here because we know the sum of the squares of each leg is going to equal the square of the hypotenuse, and then that's what we want to find. So just substituting in these values, any square root we want to simplify here, so that's what these bottom steps are showing. This is what's also nice about the CAS, and one of the reasons why it's not permitted on the ACT is if you typed in the square root of 52 on a CAS Inspire, it simplifies the radical for you. But here we're just factoring out a square root of 4, so the final exact answer becomes 2 radical 13. Now, sort of translating this or deriving the distance formula from Pythagorean theorem, we could look at the first ordered pair and second ordered pair again as x1, y1, x2, y2, and kind of bring in the delta x and delta y in this case, which is just going to be the length of the horizontal leg for delta x, and delta y is the length of the vertical leg. So if we get that the distance, or the hypotenuse squared, is equal to delta x squared plus delta y squared, we could replace delta x as the difference between x2 and x1, and delta y is the difference between y2 and y1. And then solving for d, we then at the very end take the square root, and this is the distance formula. So using this instead of looking at a graph, substituting in our x and y values, carefully calculating, this is what we have once we substitute all those values in. And we still get square root of 52, which simplifies to 2 radical 13. All right, go ahead and pause the video now. Continue with problem set 6 on the gift. Now again, just like with slope, you want to work out the distance formula algebraically, draw the right triangle, plot the 2 points, and then draw the right triangle indicating what delta x and delta y are on the graph. And that's enough to support your work for problem set 6 here, graphically that is. All right, only proceed now if you are complete with those 4 problems and wish to see the answers. Again, make sure that they're in simplest radical form. All right, and that concludes this Inspire document video that goes along with the midpoint, slope, and distance gift. Please let me know if you guys have any questions.